Hello friend, welcome. In this video, let's talk about double colon. Okay, colon. What is that in Haskell? Let's get started. GHCI Glasgow Haskell compiler interactive. Okay, so Control L. Haha. So what is colon? Colon is used for um, to show the type of something. Okay, to show the type of something. Something can be a function, or function is just like top class citizen, right? So anything has a type in um, Haskell. So for example, a number 3, right? What is its type? Okay, let's see. So type of 3. Wow, it's like a function, right? The result is just itself. So this is called a class. So in a class is like a group of different types, because 3 here can be an integer, right? Or it can be a decimal numbers. So if we want it to be a integer, we can use this to integer. So it's an integer, right? If we want the 3 to be a double, yeah, it will be like that, or float. So it's like this one can specify its, right, its type, float. Yeah. And so we defined, right? Remember, we defined our factorial function. So with double colon, we can define the type first, then followed by the implementation. So this is how we do it. Remember, let is only needed inside this GHCI environment. In the text file, like our Haskell script, right? We don't need let. So let here, like a factorial of n. No, this is our implementation. We are not going to do the implementation now. We'll show its type. So its type is, okay, so we'll limit our argument to the type of integral. So here is this equal arrow thing is show the real type of the function is an a, right, map to another a here, right? An integral number map to another one, right? Factorial, for example, for factorial 5 is equal to 120, right? So now this is the type definition of our function factorial, right? This is for its type. The type is like that. Or if we want to, yeah, we can use the default. So I think we can get rid of that if we use the different default type for this guy. Haskell will try to infer the type of a, right, the argument. Now let's go to the implementation. Fn yeah, equals if n is 0, then 1, else n times n times factorial of n. Can we do that? We need a space n minus 1. That's the shortest one. Oh, it looks ugly. So times that. Yeah. So enter, and what is that? Oh, so it means we cannot get rid of. Okay, so let's do it again. Clear. So that we cannot get rid of the integral, the type of the a. Okay, so f factorial, the type of the function is, we need to show the type of the argument, integral a like that, right? So this means the function type is that, from an integral, right, mapping to another integral. Now we can put the implementation here, equals if n is 0 then 1, else n times factorial of n minus 1. That, okay, now it works. F5, yeah. So this is the type specification, right? Okay, that's excuse me. So without that, it still works, right? In our previous video, we don't specify the type explicitly. So now, after we understand what this guy is, it's good practice to always make our function type explicit. So let's try the GCD. Okay, G for GCD, what is its type? Yeah, still integral. Now m, no, still a, right? We only need one type of the argument, is so like that. We need, right, two parameters and return two arguments, two integral arguments, and return another integral. For example, 24 and 18, no, 16, we get 8, right? Oh no, this 8. Okay, no palm here. And you can also, yeah, after we introduce the curried function, so we can also think of this as like with one parameter argument, it returns a function which accepts an argument and return a value. Okay, they are equivalent, they are same. Yeah, if you, yeah, it's up to you. You can think of this, but better to think in a cool way, right? Accept. We accept one argument and return a function, right? That function accept one argument and return a value. Yeah. So that's it for the type specification. Now the GCD of mn, right, equals if n is 0 then it's m, otherwise is g of n and mod mn, that, yeah. So g 24 and 16 will be 8. So this is a good practice to always specify the type of our function, right? The complete definition is that, and the function is actually, right, mapping two integrals, right? Integral numbers to one integral result. And now let's try some other simple functions. Okay, so for example, let's check the type of this guy, right? So the built-in function plus, that's their function, their data type. So it's an, right, the argument is a type within the class of number num. Okay, and add, right, the plus sign is the function to map like two numbers into one number, or you can think this way, it maps one number, right? This function maps one number to a function, that, like that. Yeah, so we'll introduce this curly function idea in the future videos. Okay, so I think that's it for this video. Thank you for watching. See you next